Okay, so we've got two different situations going on here. These are an absolute value inequalities. So they are going to have two answers to them, but because of the less than and the greater than, we're going to get a shaded region. Okay, so first of all, less than. Now the way I remember these less than, it's basically an and problem, and that helps me. The way that I use to memorize that is remember the word land, less than, and land. Okay, the greater than is a greater. It has the word or in it, greater. Okay, so this is an and this is an or. Let me show you how the and works. The easiest way, I think, to do that is turn this into a compound inequality since it's an and we're going to shade the overlap in between. So what I do whenever I see an absolute value, I drop it down, 2x plus 5. It has to be less than 13. Notice I dropped the absolute value bars because I'm also going to say it has to be greater than negative 13. Okay, that takes care of the and part, and it turns it into a simple inequality just like you guys learned earlier on. So subtract the 5, subtract the 5, subtract the 5. Negative 18 is less than 2x is less than 8. And then we divide everything by 2. So negative 9 is less than x is less than 4. You can have your number line here. We'll put negative 9 way down there. 0, 4. Open circles, both at 4 and negative 9. And since the x is in the middle, we shade in the middle. Like so. Okay? That's an and problem because the original was a less than. Now, if the original was a greater than, that's going to be an or problem. So this, we need to split it up into two different problems. 2x minus 7 is greater than 17, just like the original. That's the positive case. Now the negative case. If you're going to do the negative case, you have to do 2x minus 7 is less than. Notice I flipped the sign, and I need to add a negative in. Okay, the negative case gets the negative, and that's why we need to switch the sign. Okay, so I get rid of the 7 first. I add the 7 over, add the 7, makes 24. 2x. Divide by 2, x is greater than 12. Or, okay, because it's a greater, the original problem had a greater than, so that's why it's an or. Add the 7 over. That makes negative 10. And divide by 2, so x is less than negative 5. So here's our compound inequality. It's got an or because the original had a greater. The original over here had a less, so we turned it into a compound one like that and solved it like the three-headed monster. In this one, we're going to graph the number line again. We're going to put negative 5 on there. We're going to put 0. We're going to put 12. You got to decide open or close circles. First of all, open at 5. It's shaded to the left. Open at 12. It's shaded to the right. And I'm going to go ahead and shade those. Since it's or, we go ahead and shade both sections no matter what. We don't care if they overlap or not. And that's how we do the compound and or problems.